Hi there. Welcome to your lesson on solving rational equations. Tough topic. Let's get started. Let's take some notes. I provided you with a notes page to use for this video. Grab that now and let's do the examples together. Here's my first question for you. You have this given to you here and this given to you. What is the main difference between these two things, would you say? What is it? Well, I think the main difference is that the one on the left here is just an expression. It's the addition of two fractions, but is an expression because there's no equal sign. This one, however, has the same addition of the same two fractions, but there is an equal sign. So this is an equation, whereas this is just an expression. And there's a very big difference in how we can work with these algebraically based on the fact that one is an expression and one is an equation. Let's take a look. So over here, and this is what we did in our last lesson, we looked at how to add or subtract or basically combine two fractions like this, right? And this is an algebraic fraction here. What we can do is make a common denominator. Once we have a common denominator, we can combine those fractions. Right now I see a 4 and a 3. Therefore, I'm looking for the lowest common denominator. And in this case, it will be 12 because we can multiply this by 3 to get 12 and this by 4 to get 12. So let's do that. I'm going to multiply this entire fraction here by 3 over 3. Because 3 over 3 is just a version of 1. 3 divided by 3 is 1. So if I multiply 1/4 by 1, I am basically not changing it at all. It might change what it looks like, but I'm not changing what it actually is. And then over here, I'm going to multiply this by 4 over 4. So our new fractions are 3 over 12 plus 4x over 12. Now we have a common denominator. We can add those across the top and combine. And when we do that, they are now one fraction, and it is 3 plus 4x over 12. Now let's look at the one on the right, the one that's an equation. In this case, you can begin kind of the same way by saying, I have these two fractions on the left side. I want to combine them before I solve this equation. We can do that, but soon you're going to discover there's an easier way, and I'll show you that in a moment. But let's begin by doing the same thing. We're going to combine these. And we've already done the work of combining those here. So I'm going to replace those two with this. So imagine taking these same steps and doing it here. So we have 3 plus 4x over 12 equals x over 8. We have this equation. Now that we have an equation, our goal is to solve for x, right? Here we weren't solving for x. We were just combining the fractions and making a new expression in a simpler form. Here we have an equation, so that tells us we can get an answer, x equals something. So usually when we have a fraction equal to fraction, we can use what is called cross multiplication. We will multiply 3 plus 4x by 8 and 12 by x. So 8 times this over here equals 12 times this, cross multiplying. Now we can go a little further and solve for x, right? 8 times 3 and 8 times 4x is 24 plus 32x. And then get all the x parts on one side. So I will subtract 12x over here, and then I'll move the 24 to the other side. So I have 20x equals negative 24. And finally divide by 20 to get negative 6 over 5 when you reduce that fraction. So that's one approach, but I'm going to show you another approach because in the beginning I said there's kind of an easier way to look at this. Let's take a look. So instead of combining these two fractions in the beginning, I'm going to look at the entire equation. Okay, and this only works when we have an equation with fractions or a rational equation. Look at the entire equation, look at all the denominators, and you think, what is the lowest common denominator across all of those? So we knew the lowest common denominator for 4 and 3 was 12. But what number does 4, 3, and 8, what number do all three of those go into? Well, the lowest number that all three of those multiply into is a 24. So what I'm going to do is take my entire equation and multiply by 24 on one side and 24 on the other side. Because when we have an equation, we have to do the same thing on both sides in order to maintain the balance of that equation. Over here, again, we multiplied each fraction by a version of 1 to make sure we weren't changing anything, we're just changing the look of it. Over here, as long as we do something on one side and do it on the other side, we can also freely do that. So look for the lowest common denominator and multiply both sides by that. Here's what happens. So this 24, you multiply by the 1/4, and basically think of that as ending up with a 24 on top of this fraction divided by 4. So what's 24 divided by 4? This will be 6. Now 24 multiplies the next fraction. So again, imagine the 24 is on top of that fraction, 3 on the bottom. 24 divided by 3 is 8. So let's take a look. Again, this turned into 6 because it was 24 over 4. This turned into 24 over 3, which reduces to 8x because 24 divided by 3. And on this side, again, imagine that 24 ends up on top of that fraction. We can simplify the 24 and the 8. So 24 divided by 8 is 3. So basically, by finding the lowest common denominator, we're able to multiply by it, and it cancels away in each fraction because each of those numbers in the denominator goes into that lowest common multiple there, right? So here's a simplified equation we have. Very easy. Now we can move 3x over there, so subtract 3x, move the 6 on the other side, and guess what? When we solve for x, we have the same answer. So maybe you're wondering, why show two ways if they get us to the same place? Well, you'll see very soon that maybe your mind was telling you, use this approach, combine those first, and then proceed. But you're going to see that this approach is actually much easier when we have more complex fractions. So let's take a look a little bit further. So here is now we have two expressions here. These are not equations. Again, we're back to just expressions. There's no equal signs here. So remember these, our goal is also always to create a common denominator maybe, and then combine things. But let's see. The first one, first of all, is not even addition or subtraction. It's just division. So that one, if you may remember, when we have division, we're going to write the reciprocal of the second fraction. That means flip it over. But also in that first same step, I factored all my terms. All right. So 4x minus 12, I factored out a 4 from there. So you can see 4 times x minus 3. Then when you flip this fraction, this x squared minus 49 ends up on top. And that's the difference of squares, which factors into x plus 7x minus 7. And then this x squared minus 14x is now on the bottom. And from that, I can factor out an x, which I did here. So remember, division turns to multiplication with the reciprocal. Everything's factored. And with these ones, remember, it was just a matter of canceling things that are common. Is there anything that can be canceled here? I don't think so. So we just wrote the top here across the top, these ones on here, combine them into one fraction by multiplying across. However, I can see the 16 and the 4 here was canceled. That became a 4. And that x squared and this x, we had some cancellation, which is just x. But the other factors here remain because none of them are identical, cannot be canceled. So that's just kind of taking us back a couple of lessons, reminding us how to deal with fractions, right? Let's look at the next one. This one is now subtraction. So we need a common denominator. And remember with these, again, there's no equal sign. So we have to multiply each fraction by whatever we need to make a common denominator. In this case, I see x plus 2 here and x here. So the common denominator will have to have an x and an x plus 2 in it. So I'm multiplying this side by what it is missing in the denominator. It doesn't have an x, so I'm multiplying by x over x. Over here, this denominator has an x, but it does not have x plus 2. So I'm going to multiply by x plus 2 over x plus 2. Again, these are just versions of 1, so we can do this without actually changing what we have. Let's multiply. That equals here 7x, and here x times this gives us this denominator, which is that common denominator we're working towards. Over here, 5 times x and 5 times 2, so we have 5x plus 10. I kept the minus sign in between here. And again, x times that gives us that denominator. So that was our goal, make the common denominator, and that's what got us there. Now we have these common denominators, so we can subtract across the top. 7x minus 5x is 2x. And then this negative applies to this 10 as well, so minus 10. And then we have that common denominator there. So again, this is just a reminder of what we've been doing until this moment in time, just so we keep all these kind of processes straight. This is how we deal with subtraction and addition of expressions. And now let's jump back to equations. So here are two equations. And so two equations. And we're going to try both methods to make sure you get comfortable with both approaches and then see that eventually the lowest common denominator approach is easier. So let's look at this one. Let's combine these first. So we need a common denominator. What are you going to multiply each of them by? Or what's the goal for the common denominator here? Well, I hope you're thinking that common denominator should be 20 for both. So in that case, this fraction should be multiplied by 5 over 5. And this one should be multiplied by 4 over 4. Let's do that multiplication. Then we have 5x plus 12x. And then 20, we created that denominator of 20 here. So those can now be combined. So we have 17x over 20 equals 2. This is pretty easy to solve, right? We multiply by 20 to get just 17x here. and then we divide by 17. So multiply by 20 first to get 40, and then divide by 17. So that's our answer. That doesn't look so bad. I was kept telling you this method that we're going to do now is easier. And for these simple ones, both methods are, I would say, equally easy. But again, once this gets more complex, you'll see why this second method is easier. Let's try the second method now. So in this case, rather than combining these fractions first, we're going to think about what the lowest common denominator is, which we know is 20, because we just have 4 or 5 and there's no fraction here. And we're going to multiply this side by 20 and this side by 20. And it basically allows us to skip a step here. Let's take a look. So I'm multiplying this side by 20 and this side of the equation by 20 also. Now 20 times this first fraction, the 20 and the 4 will cancel, and it'll be 5x. Oh, actually I wrote it out here so we can see the full thing. 20x over 4, and then the 20 times this one becomes 60x over 5, and over here we have 40. So now again, and I would suggest in the future you skip this step. Like I was saying, 20 times this, you think about 20 and the 4 canceling, and it actually is 5x. And then over here, 20 times this, think about the 20 and the 5 canceling to become a 4, and then 4 times 3x is this. And from this fraction, we get the same place, right? Okay, so we have 17x equals 40, and we get to the same answer. Again, you can see this is slightly more efficient, particularly if you skip this step and went right from here to here. Okay, pause it if you need to here. Make sure you really understand, because this is going to get a lot more difficult in just a moment. Okay, so let's try another one. Here's a much larger equation, rational equation. There are fractions all the way along here. We have addition on this side, addition on this side. And we're going to try the method of combining and solving first. So in other words, combine these two fractions on this side, combine these two on this side, and then proceed from there. And I think in this one, it will finally be clear why the second method is much more efficient. But let's do the longer way here, just because a lot of students, this is their first thought anyway. So let's try it out. Okay, here we need a common denominator. Well, looking at those all split up, there's a 2 here, there's a 4 here. Well, we can turn a 2 into a 4. So all we need to do is multiply this one by 2 over 2, because that'll turn this denominator into 4, and then we'll have a common denominator and we can add. All right, how about this side? I see a 6 and an 8. What is the lowest number that both of these can be multiplied into? Well, that number is 24. So in this case, for this fraction, I'm going to multiply by 4 over 4. That'll make this 24. And this one, to make 8 turn into 24 here, multiply by 3 over 3. So I will get a common denominator. So let's do that. Over here, multiplying this through, 2x minus 6, and there's our denominator of 4. This one was not multiplied, so we leave it here. Here, multiplied by 4 on top, 4x times 4, 16x, 4 times 7, 28. On the bottom, 24. And over here, multiply everything by 3, and we get to here. Now we have those common denominators on both sides, so we can simplify or combine the fractions on each side of the equation. So these combine to 5x minus 7, because we have 2x plus 3x and negative 6 plus negative 1. There's our common denominator. And over here, 16x minus 15x and 28 plus 3, we get x plus 31. Okay, so it was kind of a lot we had to do just to get to this point. Now we have a fraction equals a fraction. We can do what I said before, the cross multiplying. So 5x minus 7 times 24 and 4 times x plus 31. And we get to this, all right? 4 times that, 5x minus 7 times that. Multiply through 4x plus 124, 120x minus 168. Now getting the x's on one side and just the constants on the other. I have 116x because I subtracted 4x, and then I'm going to add 168 over here to get 292. And finally, divide by 116 to get this decimal. Okay, so clearly there's a lot that was happening there. Kind of a lot in one problem to get to the answer, right? And this is, again, the method where we combine the fractions on each side by making a common denominator. But since this is an equation, we don't have to do this method, right? If there was not an equation here and we were just given this right here, the left side in the beginning, we would need to do this to combine them. But with the equation, we have this shortcut we talked about. Let's try it out. So let's try this now using the other way, where we think about the lowest common denominator for all 4 now, not just these 2 and these 2, but all 4 fractions. What's the lowest number that all 4 of these will multiply into? That number is 24, okay? All these numbers go into 24. So I'm going to multiply this entire side of the equation by 24, and likewise over here. So now think about again, when you multiply 24 times this fraction, that 24 and that 2 will cancel, and you'll get what? Well, 24 divided by 2 is 12. So we have 12 times this, right? And then the next one, the 24 and the 4 will cancel, and it'll be a 6. So you'll have 6 times this numerator, and on and on. Let's see what we get. So again, 24 divided by 2 becomes a 12. So I have 12 times that. Plus 24 divided by 4 here is a 6. So 6 times this. And keep going on this side. 24, and if 24 was on top of this fraction, 6 on the bottom, 24 divided by 6, you end up with 4. So 4 times that. And over here, 24 divided by 8 is 3. So 3 times that. I hope that makes sense. Once you get kind of this step, or you feel confident about this step, you'll see how easy these are to work with, okay? So choose the lowest common number they go into, multiply both sides, do the cancellation, and you have that. Now we have an equation with no fractions. All we have to do is multiply through parentheses, combine x's, and so on. Let's try. So over here, 12x minus 36. This one becomes this. 4 times 4x plus 7 becomes this here, and 3 times that becomes this. I'm going to combine things. Check your work as you go. And guess what? We get to the same place that we did as when we did it the other way. X equals 2.52. Kind of rush through these algebraic steps at the end here, but you should be definitely comfortable multiplying through parentheses, combining x's, and so on. All right. It might not seem like it, but this way is much simpler. I mean, compare them side by side. You'll see much easier to do the cancellation of all the fractions right away like this. Okay, so let's keep going. Here's another one. Let's try again the longer way and the shorter way. So the longer way here, I see 2 fractions being added here and only 1 fraction here. Okay, so let's add these up. We need a common denominator to add these. So ignore this 5 over x minus 2 and just focus on this side. This fraction has x times x minus 2 in the denominator, but on this fraction, we just have x. So this second fraction needs an x minus 2 introduced into it to have a common denominator. So what we're going to do is multiply that fraction by x minus 2 times over x minus 2, okay, a version of 1. Then we will have a common denominator here and here. Okay, so that brings us to this. Now that we have a common denominator, we can add them. 10 plus, and then 4 times this, which is 4 times this right here. Okay, so I'm going to, I think, took it a little step further here, multiplied these through 4x and times negative 2 is negative 8. So 4x plus 2 is what this top turns into here. Now we have a fraction equal to a fraction. We can cross multiply. Let's do that. 4x plus 2 times x minus 2. And 5 times this one becomes 5x because I just multiplied the 5 by that x in that. Okay, multiply some more. We're going to get quadratic this time, all right? Or maybe not, actually, because they cancel. 4x times x is x squared. Oh, no, you know what I did? Let's pause here. I noticed there's an x minus 2 here and an x minus 2 here. So why not just cancel them both sides, right? We can actually divide by x minus 2 on both sides, cancel it, it's gone. So we're left with just 4x plus 2 equals 5x. And that's easy to solve. We have x equals 2. However, I want to show you one other thing to consider when solving rational equations. It is this. When we get an answer, we have to make sure the answer is okay when we go back to our original. And we were doing this before when we were talking about having things that x cannot equal to, restrictions on x. This time, we see x equals 2 as our final answer when we solve this. But if x equals 2, imagine you put a 2 in this denominator here. 2 minus 2 is 0. Or if you put 1 here, 2 minus 2 is 0 again. 2 doesn't work because it turns these denominators into 0. So this solution, although algebraically we get that solution, it is a solution that doesn't work. And what we call that, we cross it out and we say, well, that's an extraneous solution. So there are no actual real solutions to this one. We got this, what's called an extraneous solution, which is no good. All right, let's try that using the other method. We are going to try the method now where we don't combine these. We think of the lowest common denominator for all 3 fractions and multiply both sides of the equation by that. So we kind of already know the lowest common denominator is x times x minus 2 because that's what we have here. Here we have an x, here we have an x minus 2. So if these 2 here can just have a little bit extra, we can have that same lowest common denominator. So I'm going to multiply that side of the equation by x times x minus 2, because that's the lowest common denominator of all three. And this side, I'm also going to multiply by that. Okay, now this is a little tougher because before this we were just dealing with numbers and canceling things, but here it's a little more algebraic, right? But again, this is our lowest common denominator because that's what all three of these can turn into very easily, right? This is already the full lowest common denominator. This one, if you multiply by x minus 2 over x minus 2, you get the same. And here, if you multiply by x over x, you get the same. So that's our lowest common denominator. The lowest common denominator needs to have a piece of every denominator in it, and this is what has a piece of every denominator, right? Now, multiply this by this first fraction, and what cancels? Well, the whole x times x minus 2 cancels in that first fraction, so we'll be left with just 10. And then when you multiply the second fraction by x times x minus 2, well, the x's cancel, so you'll be left with 4 times x minus 2. So let's take a look. See, that first one is left with just a 10 because the x times x minus 2 cancel. In the second one, the x is canceled and we're left with just this x minus 2 times 4. And on the right side of the equation, when you multiply by that lowest common denominator, the x minus 2 cancels. So we're left with just 5 times x, which is this. All right, much simpler than combining these and so on, right? In one step, we're able to cancel away all the fractions. Now, let's simplify that. 4 multiplies through there. Couple more steps and we get to our same answer, x equals 2. However, as we noted last time, it is extraneous, but we are focusing on the process here. Okay, that's a lot, but you're doing really well. Let's try some more. But before doing more, let's do a little bit of a flashback. Flashing back to the beginning of this video where we began with what's the difference between two things like this, right? Here we have just an expression, some fraction plus another, no equal sign, it's just an expression. So in that one, we have to simplify by multiplying by versions of 1, right? Whereas the second one is an equation, which we can deal with it by multiplying by lowest common denominator. So let's compare again. Here we have this. We want a same denominator in order to add these. So this one needs an x minus 2 in the denominator in order to have a common denominator. So I'm multiplying by x minus 2 over x minus 2. And over here, it needs an x minus 6 in the denominator in order to have the same denominator. So I'm multiplying by that. Okay, when you multiply this here, you get x minus 2 over that common denominator. And plus, over here, you multiply by x minus 6 over x minus 6. You get this. Combine those. Oh, I don't know if I showed the last step. Anyway, you can combine those now. I think I have it. It's going to appear in a moment. But the bottom one, since we have an equation, remember the shortcut, if you can multiply by the lowest common denominator, it will allow you to cancel the fractions. We'll take a look at that one in just a second. But my question to you is, what will that thing be that you multiply this by and this by? What will you multiply by here and here? Well, we'll find out in just a second. And this one, I promise we go back to it. Well, there it is. When you combine those, it becomes this. Okay? So again, pause for a moment. When we have an expression, no equal sign, your job is to make a common denominator, combine them. When we do have an equal sign, we find the lowest common denominator. Don't worry about combining those. Just multiply both sides by the lowest common denominator and cancel some stuff. Let's try. Okay, let's continue with this one then. So here we were going to look at what is the lowest common denominator across all three fractions. Because again, rather than adding up these two fractions and then continuing, we're going to try to cancel all the fractions by finding the lowest common denominator across all three. But to do that, we need to know what the multiples here are. So we need to factor this. So let's factor this to begin. Well, when you factor this trinomial, you have x minus 6 times x minus 2. So now looking at the denominators here, I think you can clearly see that all the denominators have what we see here, right? X minus 6, x minus 2. So this one has all the multiples in it. This one only has x minus 2. This one has only x minus 6. But the lowest common multiple, the thing that all of these can go into, is this. So why don't we multiply both sides of the equation by that? That's our lowest common denominator. So multiply this side of the equation by that, and multiply this side of the equation by that. And now what happens when you do each of the multiplications? What cancels? Okay, in this first multiplication, the x minus 6 cancels. So we're left with just x minus 2. In the second multiplication, the x minus 2 cancels. So we're left with x times x minus 6, which we see here. And on the other side of the equation, we notice that both of these factors will cancel with both of these. We're left with just 4. Now it's a very easy to solve equation, right? Let's multiply this out and see what we have. Well, x squared minus 6x here. I see x squared and x. That means we're going to have to create a trinomial and maybe factor it to solve. So I rewrote this like this. I have that 4, move that 4 over. I have now negative 6, and there's my 0. We need that 0 to solve this quadratic. So now factor this one and solve. Well, the two factors are x minus 6 and x plus 1. So our two solutions are x equals 6 and x equals negative 1. However, don't forget to check for extraneous solutions. Does one of those solutions turn one of the denominators in the original here into 0? Well, definitely, x equals 6. If you put 6 in here or 6 in here, you'll end up with 0. So we cannot have that. That one is therefore extraneous, and x equals negative 1 is our only true solution to this equation. Pause if you need. This is our last kind of big example. This is how you solve rational equations by multiplying by the lowest common denominator on both sides. And again, we don't need to multiply by a fraction of things because we're doing the same multiplier on both sides. That maintains the balance. Okay, again, last example. Now there's 3 for you to try. So good luck with these. See if you can solve these 3 using the method we just learned. Okay, what's your answer for number 1? And now check your work here. So I'm going to just have it all appear here, and you can follow this without explaining everything because we've gone through this process. However, we're looking for lowest common denominator, so I factored this difference of squares into x plus 2, x minus 2. Then I noticed my lowest common denominator is that x plus 2, x minus 2. Multiplied by that on both sides. Take a look at what canceled, right? In the first one, x plus 2 canceled, and so on. And then I did use some algebra to take it to the end, x equals 1. Pause and check your work carefully. Next one, what's your answer for number 2? And now let's check our work here. So in number 2, again, factoring this trinomial, x squared minus 6x plus 8 into x minus 4 times x minus 2. That is our lowest common denominator because that's what we see as the factors over here. So therefore, multiply both sides by x minus 2 times x minus 4. That's our lowest common denominator. And as you multiply, be careful about the canceling, right? The first multiplication, x minus 2 and x minus 2 cancel, and you're left with x times x minus 4. In the second fraction, x minus 4 cancels, so you're left with x minus 2. On the right side of the equation, both x minus 2 and x minus 4 cancel, you're left with 2. Follow through with the algebra, you get 2 answers because we have a quadratic trinomial that is solved into 2 answers. However, the 4 is extraneous because putting a 4 back in the original here, we have a denominator of 0, so our only true solution is negative 1. And number 3. Check your work now. We multiplied here, you can see, by this full lowest common denominator. So a little more going on here, right? When this first one was factored, the trinomial in the bottom of the first fraction was this, and our second fraction is this. Notice there is no common terms at all. Therefore, the lowest common denominator has to include all those terms, and that's why we're in red, we're multiplying by all 3. That's our lowest common denominator. That's the only way we'll get all the fraction denominators to cancel. In the first one, multiply by all 3. 2 of them cancel. You're left with 2x minus 4 times x plus 2. And in the second side of the equation, only the x plus 2 cancels. Therefore, you have 2 times the other 2 factors there. Carrying through with the algebra, notice everything's multiplied through here as well. And the 2 is multiplied through, moving everything to one side. Well, in this case, the 2x squared and 2x squared cancel and brings us to just x equals 2. All right, however, x equals 2 is extraneous because putting a 2 in at the beginning in the x minus 2 factor will create 0. Therefore, there are no solutions here. There's just that extraneous one. Finally, to end things off, I have a little bit of a challenge for you. Those may have been challenging enough already, but hey, why not challenge yourself some more? If you want, I'll leave this kind of optional, but you know, optional never means optional. You can do this thing. These are the same process, but there's definitely more kind of going on, right? Because we have to factor this one and the second one and the third one. You're going to end up with all these factors and then really think about what's the lowest common denominator, using a piece of every denominator, and how will you proceed? So here's 3. Give them a try. And here's the answer for number 1 of these challenge ones. Pause if you need to. Here's number 2. Again, pause if you need to there. And here is number 3. Once again, pause if you need to. All right, those were definitely more challenging. Wow, lots of algebra, but you are an algebra master. Great job. We'll see you soon.